This is Algebra 1B Part 1. We're in the Unit 2, Exponents and Exponential Functions. We're looking at Lesson 6, Division Properties of Exponents. So I'm going to derive or show you how these work, but I'm going to show you a little bit of a long method, then shorten it. So I'll give you the rule that shortens it. So the first rule is called the quotient of powers. Quotient of powers. A quotient is just a division problem. Quotient of powers. And division means fraction, right? So if I say I have x to the sixth divided by x to the third, x to the third. That is a quotient of powers. We have power x to the sixth, power x to the third. Okay? All right, so here's the way it works. I'm going to write this in expanded form like we've done before. X to the sixth means x. Notice 6 doesn't appear. It's simply x multiplied by itself 6 times. X to the third is x. Okay? Now we get to where we do something called canceling. Just so you understand, what's going on when you cancel is this. You're saying x divided by x is 1 because anything divided by itself is 1. X divided by x is 1. And 1 times anything doesn't matter. Multiplying by 1 doesn't change an answer. And that's what's going on when we cancel. We cancel an x and x. We're canceling out 1. X divided by x is 1. X divided by x is 1. So this is literally 1 times 1 times 1 times 1 times 1 times 1 times x times x times x. So this is just x to the third power. X to the third power. Okay? Now the question comes, is there a shorter way to do this? Right? And there actually is. Take a look at the 6 and the 3 and think for a minute how to get an answer of 3 out of that. Right? And the answer is we subtract. Right? So subtract the powers, subtract the exponents when dividing powers. So 6 minus 3 is 3. Okay, let's try one more. Let's say we've got 4a to the third. 4a to the third over 2a, and I'm just going to leave it as a. Okay. Now, when there's no power, no exponent on a base, the power is assumed to be 1 because a to the 1 is just a. Okay? I'm going to use the shortcut method, and then I'm going to go back and do it the long method to confirm that it works. So a to the 3 divided by a to the 1, a to the 3 divided by a to the 1 is a to the 3 minus 1. 3 minus 1 is 2. So subtract, and you end up with a to the second. Okay? And then the 4 and the 2, those aren't powers, those are just numbers. So that's pure division. 4 divided by 2 is 2. Okay? And again, let's just write this out. Let me expand things here a little bit. 4, by the way, is 2 times 2, and you're doing some canceling when you divide 2. 2 times 2, and a to the third is a. And 2a, and let's cancel. We can cancel a 2 factor. 2 divided by 2 is 1. A divided by a is 1. All that's left is 2aa, or 2a squared. Okay? Now that's when the power on top is bigger than the power on bottom. Let me show you what happens when the power on bottom is bigger. Let's say we have m to the 5th over m to the 9th. M to the 5th over m to the 9th. Let's expand it. And that is m. That's m to the 5th. M to the 9th is m, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and let's cancel. M divided by m is 1. 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 Anytime you cancel out everything out of the numerator, what is left is 1. Okay, so what's left? What remains? Well, looks like we have 1 on top and 1, 2, 3, 4 m's on bottom, so m to the fourth. M to the fourth. Now notice what happened. We didn't go 5 minus 9, right? Because 5 minus 9 would actually be negative 4. By the way, that's another way to write it. M to the negative 4 is correct, but we wrote m to the 4 on the bottom. You can recall that negative exponents mean move it across the fraction bar, so this is 1 to the negative 4, m to the negative fourth, or 1 over m to the fourth. Or the way I think of it is this. 9 is bigger than 5, so write the m on the bottom of the fraction and subtract 5 minus 9, or 9 minus 5. So take the one with the biggest exponent, write the variable there. So let me give you one more example using that principle. So I'm going to have x to the third, y to the seventh, over x to the fifth, y to the second. Okay? So we're going to do a little bit of both here. And we're going to do it the short way. I'm not going to expand it. You can always expand it. If you're not sure about the rule, expand and cancel. It'll work. So I look first at the x's, right? I have x to the third and x to the fifth. I have an x on top and bottom, and I'm going to sneeze. Bless me. All right. So 5 is bigger than 3, so I'm going to write the x on the bottom. 5 is bigger than 3, and the x to the fifth is on the bottom, so I'm going to write the x on the bottom. And then I'm going to subtract 5 take away 3. Big take away small. 5 take away 3 is 2, so x on the bottom is x squared. Y to the seventh and y to the second. 7 is bigger than 2, so write the y on top and subtract 7 take away 2. 7 take away 2 is 5, y to the fifth. Okay? All right, so that's how to handle the quotient of powers rule. Quotient of powers. So when you divide powers with the same base, you subtract the exponents. That's the big idea. There's one more rule here that we need to master, and that is a power of a quotient. Power of a quotient. Okay? So imagine this. I have a over b all raised to the third power. I'm going to expand it, and then I'm going to show you the rule. Okay, so first let's expand it. 3, the exponent 3 touches the parentheses. Therefore, the parentheses gets repeated 3 times. So it's parentheses times parentheses times parentheses. And in the parentheses is a over b. A over b, a over b, a over b. And recall how to multiply fractions. You multiply fractions just by going straight across. Across, 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 across. This is literally a times a, or a to the third power, over b times b times b, b to the third power. Okay? And so what this turns into is a kind of distributive property. The 3 gets given as an exponent to the a and the b. To the a and the b, and ends up in both places, on a and b. Okay, let me show you an example here, like what you would do in your assignment. So we have 2x to the third over y, and I'm going to raise that to the fourth power. Now we already learned the product of a quotient, or the power of a product. We can distribute over factors multiplied. This is a combination of the two. So the 4 goes to the factor 2. The 4 goes to the factor x cubed, and the 4 goes to the y. So this is 2 to the fourth power, x to the third to the fourth power, and y to the fourth power. Now 2 to the fourth power, we can figure that out. That's 2 times 2 times 2 times 2, which is 16. X to the third to the fourth, that's called the power of powers rule. 3 times 4 is 12, x to the 12th, and y to the fourth. Okay, so using the rules, that's what we end up with. Okay, now we could expand this and simplify and all of that, and that will work. It's a little bit long, so I'm not going to take the time to do that here. So hopefully that makes sense. The power of a quotient distributes the power, the exponent, over the dividend and the divisor in the division problem and the quotient problem.